But the question is still, how do we know if this hypothesis is true or false? And that's where forms of hypothesis testing comes in. And that's largely what we're going to be doing now for the next few weeks, is figuring out different ways to test our hypotheses. So the first way goes way back to the early days of political science, and we're going to look at Mill's methods. And it's really nice to look at this even just for the logic, to understand the logic of how we might go about testing a hypothesis. So he came up with a number of different ways. I'm just going to show you two, the method of difference and the method of agreement, to take a look at seeing whether two variables were related. So just in the abstract, let's say one country or one unit of analysis has factors A, B, C, and D. And they come with these outcomes W, X, Y, Z. Now, at the same time, we have unit of analysis, the second one, that has factors B, C, and D with outcomes X, Y, and Z. You'll notice that these things, these B, C's, and D's are in common. And we know that X, Y, and Z are in common. But the thing that's different is the A and W. So the A must be related to the W. Don't stress too much if you're like, wow, this seems like, a weird IQ test. I'm going to give you a real life example and it'll make a little more sense. The method of agreement uses kind of the other logic, which could be if, again, you have a country or a unit of analysis, an individual, whatever, that has A, B, C, and D, and outcomes W, X, Y, Z. And you see another unit of analysis, say it's a country that has A, E, F, and G, and W, T, U, and V. Well, we know that these things are different. These things are different. But the things that are in common are A and W. So we can say that A and W are related. And I was not trying to refer to the restaurant. I just noticed now when I'm saying it, I'm like, wow, that's making me hungry. Okay. But we can't necessarily say in this situation which causes which. We can just say we think there's probably a relationship between A and W. Okay, so let's give you like not a real example, but like a little more concrete example that might help you a little bit understand. So this is an example with the method of difference. So we have two countries. Country A has an agricultural economic base. It's an old democracy. It's a former British colony, or a current British colony, we'll say. And then the outcomes that we notice about this country is that they have proportional representation system, and they are also a parliamentary system. Okay, so then we see country B. It has also an agricultural economic base. It's also an old democracy. It was not a British colony. And the outcomes we notice in that country are that it has a proportional electoral system and a presidential system. So using the method of difference, what might we say could be related? So we would probably notice the difference. So being a British colony or not is likely related to your system of governance, whether it's parliamentary or presidential. Okay. So this is a basic kind of logic to get your head around, and we're going to be using that also when we start looking at quantitative methods. It really builds on this sort of logic that Mill presents. But we know that the world is not that simple, although there's some amazing case study research that does use these methods still. But let's look at some other ways. Let's say we had more observations than just two. So when variables are measured on the scale and we have enough cases to study, another way we might test a relationship is using a correlation. And we are going to, in the last week of class, second last week of class, look at specifically how you calculate a correlation. But we're just going to take a basic look now at the general structure of it. So a correlation is always between -1 and 1. The sign, positive or negative, tells us whether it's a positive correlation or a negative correlation. The number or the magnitude tells us how strong that correlation is. So are the dots really tight to that line of best fit or not? So you can see here's an example of a positive correlation. So these two factors, two variables must, seem to be pretty closely related. But as one increases, the other one increases. Here we notice that this is a negative correlation. So as one variable increases, the other variable seems to decrease. And then this would be an example where there's really no correlation. There's nothing really going on between all of these points. And again, each axis here is a variable, one of those two variables, one of those two factors that we were talking about. So let's give an example that I think might help you out to understand what we're talking about. So my research in electoral management, I might be interested in testing whether a country's wealth has an impact on the quality of elections. So I make a hypothesis. I predict that higher wealth in a country will lead to better quality elections. It's based on theories about resources and individuals' desire to participate in free and fair elections. So we often call this the Lipset hypothesis or the modernization hypothesis, the idea that as you get more wealthy, as a country gets more wealthy, there's going to be more of an expectation that they have a say in politics, and so the quality of the democracy will improve. Okay, so I decided I was going to measure wealth according to GDP, so gross domestic product, and I'm going to measure election quality according to a perceptions of electoral integrity index, so essentially an index looking at how high quality the election was. So we can create a scatter plot with our independent variable down here, which is GDP, our dependent variable here, which is the perception of electoral integrity on a 0 to 100 scale, and each little dot is a country. We put all the dots. And then we can estimate a line of best fit. Does there appear to be a correlation? So we're going to look at specifically how you do that statistically, again, way at the end of the class. But just for now, you can probably tell just by kind of looking at the dots that there tends to be a positive correlation. That as wealth goes up, it appears that the perception of electoral integrity does go up at the same time. And so if we did actually a statistical calculation of the correlation, there's a 0.49, so it's a positive number, meaning that it's a positive correlation. And it's, not super low, but not super high. So, the dots are kind of close to the line, but not kind of perfectly. Like a perfect one correlation would be just a line of dots. Perfect negative correlation would be a line of dots going down. So I think you can probably get the logic of it. That's pretty much what I want you to get today. I know that there's so many more specifics, and again, we'll talk more about that later. But today I really want you to understand the logic of how this works for hypothesis testing. All right, so this is the first part of your assignment for the week, is to use Freedom House democracy measures, and we're going to talk more about that next week, but essentially it's just a way of measuring the quality of a democracy in a country, and the gross domestic product, so a measure of their wealth, to create a scatter plot and estimate a line of best fit. So you don't really need to figure it out statistically, just kind of draw a line like, I think these dots are going up, or I think these dots are going down. So I just gave, I think, like 12 countries and GDPs. You would normally do all of them, but just because I didn't want you to spend forever putting little dots on a graph, just a few indicative countries. I gave you some graph paper, and you make sure you have your axes labels, and create yourself a little scatter plot, and then draw yourself a line of best fit. Please do this by hand for this assignment. Do not go to Excel. You can make beautiful graphs on Excel, but I want to make sure you understand all the different pieces, and Excel doesn't do it for you. So do this by hand, take a picture of it, pop it in your assignment, or print out your assignment, do it by hand and scan it. And then answer the questions. Is there a correlation? Would you say it's positive or negative, strong or weak? And then also start to think about, are there other factors that you suspect might have influenced this finding? And we're going to talk about that now, about other factors. So the world is complex. Correlation does not always equal causation. Here's some graphs. Let's talk a little bit about what we think might be going on here. Okay, so this one is U.S. spending on science, space, and technology correlated with suicides by hanging, strangulation, and suffocation. So what do you think might be going on here? This is when you guys might come up with a whole bunch of funny reasons why you think this might actually happen. But it's also possible sometimes that independently two things are going up or going down for very different reasons, but they are following the same trend over time. Modernization is happening. So they're not really that related. It's just a matter of things are sometimes related to each other. And so that's why we always want to make a good hypothesis, because if I didn't have a clear hypothesis why US spending on space science and technology is related to suicides, then I really have no business doing trying to do a correlation about that. Now, it's really interesting. One student once said, like, modernization makes people more desperate and more likely to commit suicide. And I was like, oh, okay, that's something you could test. But it's also likely maybe nothing is happening. And because we didn't have a strong hypothesis getting into it, that it's possible that they go with each other, but there's not actually a relationship happening. Okay, this one here, eBay total gross merchandise volume and total Black Friday revenue. So what might be going on here? So there's a few things that might be happening. It's possible that increases in consumption in general mean that both Black Friday is more popular and eBay sales are more popular. That's why they move together. It could also be that, like, eBay sales are part of Black Friday revenue. So obviously they're going to go up together because one is like a measure of the other. So again, we're going to talk in a second about how this, why this is, what is this called, when one other thing is influencing both of those things. But it's really good to think, okay, what other thing could be influencing both of these factors? All right, the last one is just a bad graph to begin with, because, like, what is this axis? The independent variable is what generation? I don't know. Anyway, so sushi and gay marriage. So they're related. Now, does this mean eating sushi or trying sushi is going to make you support gay marriage? Probably not. Probably what's happening is that people who are socialized in larger, diverse cities who are likely to try sushi are also likely the people who've been socialized to approve of gay marriage. Okay, so I think you guys get the drift. We might find two things are related, but only because it's a spurious relationship. This means that another variable influences both the independent variable and the dependent variable. And we call this other variable the confounding variable. So independent variable, we think it's related to the dependent variable, but actually a confounding variable is influencing both. Just like right here, living in a city would be your confounding variable that influences the relationship between sushi and support for gay marriage. So let's use an example from something we've been talking about in this class so far. So I think that countries with lower quality democracy will be more likely to have higher levels of national debt. And I could make a hypothesis about that, you know, if you have poor governance, that might lead to poor management of finances. So it's a good hypothesis to make, but I always need to think in the back of my mind, what are the potential confounding variables? So some of those might be wealth levels, like those who get, because the country's doing really poor, like people who just try to get into government so they can have power however possible, and that might not be through good quality elections. It could be education levels, that there are less people to manage the economy and to run for office who have the skills to do that. Could be a development, levels of development. So newer countries are just trying out democracy and they're also in high levels of debt because they're just starting to get their economies moving. So there's always potential confounding variables that you really have to keep in mind, or else you're going to start becoming the person who makes these sorts of graphs. So let's try another one. Post-secondary education and higher voter turnout. So yeah, like that is a well-documented relationship, that if you have post-secondary education, you're going to be way more likely to vote. But is it that post-secondary education causes higher voter turnout? Some people would say yes. Some people would say you go to post-secondary education, you learn more critical thinking skills. It makes you want to be part of the government or part of voting more. It makes you feel more empowered. It makes you part of the network of people who are likely to vote. Okay, but what else? Well, maybe it's the types of people who self-select into post-secondary education are also the types of people who are going to self-select into higher voting. That could be related to upbringing. It could be related to families' social stature. It could be related to wealth. So it's always important to keep these variables in mind. So your second job this week is to try this out. So to formulate a hypothesis, again, from the social or political world, express this hypothesis in terms of independent and dependent variables, and think of a few confounding variables. And I think that'll really get your brain going to start thinking more clearly about how different variables are related and how they might not be related to. So I put the assignment is right here. It's got, again, your chart, your graph. Again, please do it by hand. Answer some questions, and then try testing, or not testing, but writing your own hypothesis. Okay, that's it for today, and I look forward to seeing what you come up with.